In this example, I have something that looks pretty daunting. It's an endless fraction because under the last denominator, there is still a 1 plus 6 over 1 plus 6 over, and so on. And so this fraction is going to go on and on and on forever. Now, if you don't get a clue from me, you probably wouldn't know where to start. But it isn't half as difficult when you have an idea of what to do. What I'm going to do is I'm going to take the whole expression and I'm going to make that expression equal to x. But you can see by observation that if I just took away the first 1 plus and I added it at the bottom, that this expression in here, in fact, is also going to be equal to x. So if I write this out neatly, I've said that x is going to be equal to that whole expression of 1 plus 6 all over. But what did I say it was equal to? Well, I told you the expression was equal to x. So if I continue with that same expression, I must have 1 plus 6 over x. If I want to work out what the value of x is, I need to first of all find my LCD. The LCD over here is the greatest number of each type of factor in the denominator. As the first two terms, the one on the left and the first one on the right, have a denominator of 1, 1 times anything is still the same, and so the only LCD factor is x. Now here I am not dealing with an expression, I'm dealing with an equation, and so I'm going to use the LCD method to get rid of the denominator in the equation. On the left-hand side, I did not have that factor, so by timesing its numerator by x, I get x times x, which is x squared. Likewise, in the first term on the right-hand side, that LCD was not in the original denominator, so I must times 1 by x. If I times the numerator of the last term by x, that x cancels with the existing x that I had in the denominator, and so the denominator in fact falls away. You can probably see at this stage that you're going to be dealing with a quadratic equation. If I have a quadratic equation, I cannot find it unless I get all my information onto one side and make that equal to 0. As it's x squared, I can have two factors to give me two solutions. And in order to find those two factors, I need to factorize. The factorization method that you're going to use here is going to be the trinomial method, which gives you x minus 3, x plus 2 equals 0. From this, I can see that I have two possible answers. The first factor, x minus 3, could have been equal to 0 to give me a 0 answer. Or the second factor, x plus 2, could have been equal to 0 to give me a 0 answer. So the first solution that I can contemplate is when x is 3, and the second solution is when x is equal to minus 2. Now, because you have put the x in, you have to go back and assess which of these x values is suitable for your answer. Looking again at the original expression that you were given, it was a positive number because I had a positive number and I added a positive fraction. And so if that number is going to be positive, there is only one possible solution that you could have used, and that is the solution when x was equal to 3. So in other words, in this answer, x is equal to 3 would give you the result for that expression.